Now in this video we will discuss if any forces is acting on a object, how to draw them. So basically we are going to discuss force. This is magnitude wise and we'll also discuss what is corresponding direction. So let us say I have a book and this book is kept on a table. So this is my table and there is a book and this book is kept on this table. So what are the forces that is acting on this book? We are interested in the forces and we want to draw them, and this is called Freebody diagram. So what is Freebody diagram? So drawing the forces on the object. So drawing the forces on object is basically Freebody diagram. So if I have Freebody diagram, when I say Freebody diagram, so what I mean I have to draw the forces. So clearly the forces. So clearly the forces, magnitude wise as well as if possible direction wise. Let us say what are the forces that can act. First force is weight. Now if I consider this book, now there is a earth and each point of this book is basically attracted by earth. So this point, this is a mass attracted by earth. This mass of this book, this is also attracted by the earth. So this is my earth. So each point is attracted by earth. So there is a gravitational pull. So basically what is weight? This is nothing but gravitational pull. So gravity is trying to pull this book. Now this pull is basically called weight. So what is weight? This is gravitational pull. Now what we do, we does not show these forces from each point, we show a resultant. So if I have a book and the forces are acting in this way, this force is from here, this force is from here, but what we will do, we will try to do one resultant force and we will pass this resultant force from the geometrical mean, and this is later we'll call this the center of mass. So this resultant force passes through the center of mass. So this is my center of mass. Right now we are not going to detail about the center of mass. So this is my center of mass, and the magnitude of this force is m mass into gravitational pull, that is G. Sometimes this is also written by W. So this is one force. Now this force is called body force because you see all the points, so forces are acting from all the point of the body. So weight is basically example of body force. Weight is a example of body force. Now let us say consider the another forces on this book. So now the next force we have, that is called normal reaction. So let us say if this book is kept on the table, so this is my table, this book is here. Now I know there is a force, that is weight, that is acting in the downward direction, basically W, and that is equals to mass times gravitational pull. If you see this object, only one force is acting, so there should be, this object should fall down. So this means this book should fall down, because if I am pulling this book with gravitational attraction mg, so this should fall, so object should fall, but the book is not falling. This means an equal amount of force that is acting in the upward direction, then only this is possible, this book should not fall. And this is this force. If you see this point of table, there is a force acting on this book up. This point of the table, there is a force acting in the upward direction. This point of the table, there is a force acting in the upward direction. So at each point of contact there is a force acting in the upward direction. Now what we do to summarize or to write resultant of all these forces, we does not show these tiny forces, we show a resultant forces, and now this all resultant forces we say this is passing through center of mass. So this force is acting in the upward direction and passing through the center of mass, and we call this as a normal. So N for normal. So normal reaction. Now you see what are the total forces acting on the book. Another force is W, that is equals to mg, and if this book is in rest, so this book is in the rest, so total force has to be 0, that is the vertical direction up force is equals to downward force. So in this cases I can say N is equals to W, or W basically equals to mg. So N is equals to mg if the book is in the rest, if book is in the rest. So we have discussed two forces, one is bait, another is normal reaction. This force, normal reaction, is called contact force because this is acting at each point of contact. So this force is acting at each point of contact, so we call this as a contact force. So normal reaction, we will call this as a contact force. So normal reaction is basically a contact force. Now third force let us consider, that is the tension. So we are now considering tension. Now if we consider the same book, this book is here kept on the table, but now somebody with a string, so a string is tied with this book, and somebody is trying to pull this book with a force F. So if somebody is trying to pull this book will move in this direction, so book will move with some acceleration. So there is this string is taut, so a string is taut now. So we will have a string and this is taut. Now if you see, this string is trying to pull this object this side. So there is a force in this string. So this string is applying a force in this object, this book. This force, the force by which this is trying to pull, is called tension. So tension is basically a pull force. So this is trying to, so tension in this case is a pull force. And sometime this is denoted by T also. So if I see this book, I have a normal reaction in the upward direction, I have mg or W in the downward direction, and there is a force that is acting, and this is tension. This is a tension, that is pull force, and we write this is a tension. Now if you see, this tension is again a contact force because this is acting between the contact at this point. So this point is basically contact between book and this rope, this string. So tension is again acting at the boundary. So tension is acting on the boundary. And this is again a contact force, and this is a contact force. Sometime in place of tension you can also have a compression. So let us say if I have this mass, let us say I have a spring here. This spring is natural. Now this spring is in natural length. Natural length, this means neither compressed nor elongated. So this length is natural length. Now if somebody try to push this spring. So now a spring is somewhere here. So this is the natural length, but now this is the only length. So in this case a spring is compressed. So a spring is basically in this case compressed. Now you can understand this spring will try to push this object this side. Are you getting or not? So this a spring will try to push this mass, let us say mass is m, in this direction. So this force is a compression force. So in a spring there is a compression, so not it's a tension, this is a compression. So this will try to push. So this is not a pull force. In this case a spring is applying a push force. A spring is applying a push force. So you can think there are only two kind of forces. Either you can have a pull force or you can have a push force. In this case force will be push, and it is denoted by F in this direction. Basically in later classes you will understand this force is also called magnitude by kx. So this is a push force that is acting on this object. Now so we discussed what is tension, what is compression. So tension in the string will try to pull, compression in the spring try to push. So this is two kind of forces. We have also said this tension is a contact force. Again compression force is again a contact force. You see there is a boundary. If I have a spring, this spring will try to push this object. So compression force is again a contact force. Compression force is a contact force. Next force we will discuss, and that is called friction. So we have discussed three forces. Now next is friction. So let us say the same table, same book. We have this book here, and this is pulled by a string with tension T. Now this surface, there are forces that is acting. This surface is not a smooth, so this surface is rough. So basically surface of table is rough. So table surface in this case is rough. So you will try to pull this one, but table will want to resist this pulling. So this will become slower. So table is trying to resist this motion. So table is trying to slow down or retard down the motion of this object. So what is happening? Table is trying to resist the motion of book. So table is trying to resist the motion of book. So this means there is a force that is acting in the backward direction. Only if there is a force in the backward direction, then only this motion will retard. And this is very true. If you see the grains are here, now when you try to push this one, so let us say this is your book. You are trying to push this, pull this one. So what happens? Grain at the surface try to orient in this way. So these are the grain boundary. I am showing exaggerated way. So these grains are basically trying to oppose the motion, and this force is called friction force F. So we can apply a friction force F. Are you getting? Now this is again friction is acting at each point of the boundary. If you see there is a friction at this point, there is a so at this point there is a friction, this point there is a friction, this point there is a friction, this point there is a friction. So at each point of boundary there is a friction, but what we do, we draw resultant friction force something like this. So this is the friction force. Once again friction force act at the contact boundary, so we call friction force as a contact force. So friction force is a contact force. So these are the forces that is acting. So if I summarize what are the forces that is acting, there are two kind of forces. You can have a body force, you can have contact force. You can have a body force, you can have contact force. Now let us say weight is an example of body force. Tension is an example of contact force. Normal reaction is again a contact force. And finally friction is also a contact force. So this we have discussed. Mainly we can divide all the forces in terms of, there are sometimes more forces like wind forces, snow forces, earthquake forces, but we are not going to consider all these because this is not a part of elementary physics course. Now let us do some small examples. So if I have a object, so first is a book kept on inclined plane. So a book on inclined plane. So we have to show the Freebody diagram. Let us say I have an inclined plane, something like this. This angle is theta, and there is an object or book, you can say, is kept here. What are the forces that is acting, you have to show. So now you have to see what are the forces, body forces. Now body force is weight. So this is my book, this is center of mass, and earth will pull in the downward direction. So if you have this center of mass and earth is something like this, so it will always pull vertically down. So earth will pull vertically down. So now this is weight, that is equals to mg. Weight is equals to mg. Now there is a normal reaction also. If you see all this point, there is a normal reaction acting in this direction. Contact normal reaction is always perpendicular or always normal to the surface. Another important point, normal reaction is always normal to the contact surface. So we can draw the resultant normal reaction in this way, because this has to pass through the center of mass and it has to perpendicular on this surface. So this is the normal reaction. Now what is the friction? How to find what is the direction of friction in this case? So it is easy to find direction of friction. What friction does? Friction always try to resist the motion. So friction tries to resist the relative motion. Right now we will not discuss what is relative here, we will go into simpler things. So we will only understand it try to resist the motion. So if you see this block or this book has a tendency to fall in this direction. So there is a force, that is a friction force that will act in this direction, that is basically parallel to the surface. So there is a friction force will act in this direction. Are you getting or not? So there is a friction force, this friction force is acting in this direction. So this is forces that is acting on a book if it is kept on inclined plane. Now the same book, but now it is tied with a string. So we have the same book kept on inclined plane. So this book is kept on this inclined plane, but there is a string and this string tries to pull in this direction. So this string is applying a tension T. So we are applying a tension T, this angle is theta. So you have to draw the forces. Easy to draw. Weight force always downward direction, vertically downward. Normal reaction is normal to the surface. So this is my surface, this is normal reaction, this is my tension. Now what about friction force? This block has a tendency to move up. So this block is trying to move up. So force will be in the friction force in the downward direction, because this always try to oppose the motion. Since this is going up, so friction will be in the down direction. So friction always tries to oppose the motion. Friction always tries to oppose the motion. Now let us say third example if we consider, and this time we have a string, and this string has a bob attached here, and this string is fixed, and this is moving in a horizontal circle. You can understand this one. Sometime this ball is here, sometime this is here, so ball is moving. Sometime this ball is here, sometime this is here, sometime this is here, sometime finally this is here. And let us say this angle is given to you, this angle is theta, and this radius in which this ball is moving, that is also given, that is r. Now if you see this circle lie in a horizontal plane. So this circle lies in a horizontal plane, and that's why we call this circle is moving in a horizontal plane. So this ball is moving in a horizontal. So this case, a ball moving in a horizontal circle. So what are the forces that is acting? Once again we have to draw the Freebody diagram. So let me write once again here. So this is my ball, and this is the circle in which this ball is moving. So a force that is a bit that is vertically downward direction. So this mg is acting in the vertically downward direction, and there is a tension. So tension is acting in this direction. Tension always acts in the direction of rope, direction of a string. And in this case this ball has a tendency to fall down, so this will pull. So tension always acts in the direction of a string. And this is not anything that has to remember, this can be easily understood. So this is the forces acting in this case. Basically if this is moving in this direction, we can write equation of motion by putting this t component of the in this direction and vertical direction. We will not go into detail here. Now let us take an example in which this ball is moving in vertical circle. Now the same thing, this string has a ball, and now this is moving in this circle. So this ball is basically moving a vertical circle. So if you see, this circle is in a vertical plane. So what is happening? This object is moving in this circle, and this circle lies in a vertical plane. So this plane is vertical plane. Ava B said this plane is basically horizontal plane. So this is horizontal plane. Now this time this plane is basically vertical plane. So this plane is vertical plane. So corresponding motion is called a stone or object moving in a vertical circle. Vertical circle. So if you draw the forces, now again mg will act in the downward direction, and this string will try to pull up. So tensor will act in the upward direction. Only two forces, body force mg and tension, that is a contact force. Now what will happen if this object reaches to the top point? So this is moving, sometime it is here, sometime it is here, after some time it is here. Let us say after some time this object is here, and this is my string. What are the forces? Again mg will act in the downward direction. So mg is again acting in the downward direction. And tension force, this string is still try to pull this in the downward direction. So you see tension is again acting in the downward direction. Important point, if you see the lowest point, so this is the lowest point, tension and mg both are in opposite direction. But if you see that the highest point, that is top point, tension and mg both are acting in the same direction. So this is another important point we have here. Now consider the next example. In this case we have a rod, and this rod is kept at this, so something like ladder. So this is a example of ladder. Now this is a horizontal floor, this is the vertical floor, and this ladder is kept inclined between these two floors. Now how to draw the forces? First is bait force, and then let's say center of mass is somewhere here, that is the middle point. Generally center of mass lies at the middle point, so bait will act in the downward direction, that is mg. Now at this point there is a normal reaction. If you see, let us say, see this ladder in a more macroscopic base. So this is my ladder. What will happen? This ladder at this corner will not remain corner. So this is the ladder corner at the lowest point. What will happen? As you put this ladder here, this will become slightly circular. So you will find this ladder will not look corner here, it will be something circular. Now this circle and tangent, if you draw on this circle, this is in the vertical direction. So what is happening? We already said normal always acts perpendicular to the contact surface, both contact surface. On this contact surface, this is the perpendicular, and this is a circular cross section, circular surface, again perpendicular in the vertical direction. So at this case normal will act in this direction. Let us call this normal reaction as N1. Now at this surface normal will act in this direction, this is N2. You will again understand this one, because this surface will look something circular, and on this circular surface if you draw tangent, if you draw perpendicular, this will has to pass through the center. So this circular part, and this is the tangent, and this surface, this vertical ball, again tangent or perpendicular in this direction. So finally normal will act in this direction. If I have to draw friction forces, so this tendency, so this point has a tendency to move in this direction, so friction forces at this point will act in the opposite direction. Let us call this as F1, because this is a tendency to move in this direction. Friction forces always try to oppose the motion of movement. Now if you see this one, this will try to move in the downward direction, so in this case friction force that will act in the upward direction. Let us call this friction force is F2. So you have to remember, friction force always try to oppose the motion. This is trying to move in this direction, friction force in this direction. This is trying to move in downward direction, friction force is upward direction. So friction tries to oppose the motion. Let us discuss the next problem. In this case we have two spheres kept in a container. So let us say my container is something like this. Two spheres are kept inside this container. So this is one sphere, slightly big, and then I have another sphere that is kept here. We have to draw the Freebody diagram. What we will do, we will draw the Freebody diagram for this sphere first and then for this sphere. If I draw for this sphere, the bait will act in the downward direction. Let us call this as a W1. And there is a normal reaction acting at this surface, call this as a R1. There is a normal reaction at this surface. Of course center will be somewhere here, because this has to pass through the center. So normal reaction R2 will act here. There is one force more that will act, and there is a contact surface. So there is a so this wall is trying to push this object this side. So there is a contact force at this point. Let us call this as a R3. So this force is basically R3. Let me explain everything once again. This object, so I am trying to finish this object first. Bait is acting, this is a body force. Now we have to look the contact forces. There is a contact surface, there is a force. There is a contact surface, there is a force. There is a contact surface, and contact forces always perpendicular, so there is a force in this direction. Now for this object, let us say same thing for this object. So this time slightly. So now my object is this, I am interested in this object. So what are the forces? There is a contact surface here, so there is a normal reaction here. Let us call this as a R4. Call this as a R4. There is a body force. Let us call this as a W2. This is basically bait, and there is a contact force acting in this direction. And this contact force has to be equal to R3. Why this is so? Because if you consider this surface, the same force, Newton's third law says, the force that applies by this object on this object is same as the force applied by this object on this object. That is, action and reaction are equal. Action and reaction force are equal. So I can say this force R3, if this object is applying on this object is R3, then this object will also apply on this objective force of R3. So this is about the forces. What are the forces? How to draw the Freebody diagram? So this is just introductory lectures. In this lecture we have discussed there are two kind of forces. One is body force, another is contact force. We said weight is a body force, friction force is a contact force, normal reaction is a contact force, tension is a contact force, compression is also a contact force. And then we said how to draw the Freebody diagram in case of inclined plane, in case of ladder, in case of two objects touching to each other, in case of a book pulled by a string. In all cases you have to remember two things. First thing is you have to see all the contact surfaces and cut the boundary, make the force. Second important point, you have to always write body forces correctly. That is, it will pass through the center of mass. If it is gravitational force, this is vertically downward, because gravitational force always try to pull a object in the downward direction.